All right, so now we're going to go ahead and terraform our Kubernetes cluster. What this is going to do is it's going to create a Kubernetes cluster in the Linode console for us. And then it's also going to provision however many virtual machines we want. In this case, we'll use 3. And so I find the easiest way to do this is twofold. Number one, you could go off of the blog post, of course. Number two is you could just use the Linode LKE cluster from the Terraform registry. This is typically how I'll do it. I'll do a quick Google for the Terraform registry for Linode or whatever provider, go into the documentation and find the resource that I'm looking for. And so this is the resource we're going to be using. So I'm going to go ahead and copy and paste this into cluster.tf. And right off the bat, there's a number of things that we're definitely going to want to change. The first one is the Kubernetes version. So, when in doubt, you can go to Kubernetes version and you can find out what the latest version is with the releases. And 1.26 is the latest release as the time of this recording. Now, the challenge with that, of course, is whether or not Linode supports that latest version, which may or may not be the case. So if we go into the Linode console and try to create a cluster, we can see what version is supported. Currently, it's 1.24. So I think we would get errors on the version that's, that we're trying to provision. So if we did a different one, we'd probably get errors there. I'll let you test that out and let me know in the comments. So that's the first thing I'm going to fix. The next thing is going to be the label itself. So this is the label on Linode. It needs to be unique for your Linode account for Kubernetes clusters or for the LKE. So I'm going to just call it Terraform and K8-cluster. Now, since I changed the label inside of Linode, I'm also going to change the label inside of Terraform. So this first one is really just the Terraform resource. So I could call it -resource or something like that. So this name has nothing to do with anything else in here. It only has to do with Terraform itself, whereas this label has everything to do with the actual API. The region itself, you can pick your region. I'm going to go ahead and do US East. I think it's a fairly good region for a lot of people around the world because this is where your users are actually going to end up connecting to, which is pretty fascinating. Next, of course, is tags. If you want to put them, you can. This is completely optional. And then finally, the pool. So this is the number of virtual machines you want in your Kubernetes cluster. So these are also known as nodes in Kubernetes, which basically means that how much compute power do you want to have across how many devices. So I think 3 is a good start for the vast majority of clusters to go with, but you could start with 10 if you'd like. You could start with 1,000. It's really dependent on how much you actually need, how much power you actually need. But if you're just learning with me, just stick with 3. I think anything less than 3, there's concerns with making sure that everything's running correctly and well, because if one of the nodes go down, you'll still have 2 back, or if 2 of them go down, then you'll still have 1, and ideally they will heal at some point as well. But that's outside the context of this one, so we'll just stick with the count of 3. The next is the actual type. So this is the Linode type, the actual virtual machine type. And finding out this ID requires us to look at the API. But before we do, you might go into Linodes and hit Create Linode, and then go down to Plan, and you can actually see all of the different kinds of Linodes here. So right now we're at the Linode 4 gig, but notice that the ID is not listed here. So to find this ID, we actually go to the Linode API. So if you did a quick search for the Linode API for Linode types, you would get this URL right here. Opening that up brings you to something like this. Granted, mine has JSON being formatted, but we can see that G6 standard 1 is a Linode of 2 gigs, which is, $10 a month as we see here. So it's that one. It's pretty straightforward, the naming once you understand it, but that's the one that I want to go off of is standard 1 because this is going to cost me $30 a month. It's actually really hard to beat that for all kinds of Kubernetes clusters. And on this cluster, we can deploy, I would say, at least 3 or 4 web applications that will work really well. Granted, the traffic is going to be an issue, so if we had a ton of traffic, then maybe not 3 or 4 applications. Maybe we would need a more robust cluster. But you could probably even get 30 applications on here and have it run reasonably well for thousands of users. Once you start getting into the tens of thousands or the hundreds of thousands, then we're looking at a more robust cluster that you'll probably need. But that's outside the scope of this. This is our cluster here. That's what we've got. So what we can do now is go into our project and make sure that you're in the root of your Terraform modules. And we can just do Terraform and plan. Hit enter. And this is going to show us everything that's happening. Now notice that there are a few items that are going to be available to us after we apply. So these items are going to become critical, but it's also available on the documentation. So if we come down, we see the arguments. These are all the arguments that we set. Then we also see the pool, another argument. And then if we scroll down even more, we've got our attributes. So this is the after the fact data here. The key one to point out is this base64 encoded kubeconfig file for our cluster. So that's something we will need and eventually to output to the config file here. And so Kubernetes with Terraform is actually pretty straightforward on how we can do that. So once we have an actual resource defined, we can use that resource and its value from one of those attributes into this content, which is fantastic. We will do that here shortly. But before we do, I want to actually think about the arguments here to actually pull them out of the actual Terraform file itself prior to applying it and use them as input variables, right? So in variables in here. Before we go any further, I want to bring your attention to something that is actually an issue, and that is terraform.tf state. Now, the reason this is an issue is you might recall we have this backend here. Why are we seeing terraform.tf state? Shouldn't that be in the backend? And the answer is absolutely it should. And the reason being is because in main.tf, we forgot a critical component, and that is backend S3 and then an empty declaration here. So I have now changed where I want to store my Terraform state. So what this means then is I need to actually run init again, which is of course this right here. So more specifically with this backend. So I'll just copy that part. I'm in the root of my Terraform project here. So Terraform init and then backend config. What's going to happen is it's going to say that it already says this. The pre-existing state was found from the local backend to the configured one. No state was found. Do you want to copy this state to S3? Yes or no? And the answer is going to be yes. I want to copy that original state. So that's how easy it is to move things over. So once it's all moved over, I think we should be okay as far as our backend is concerned. And then we can actually go into our object storage, refresh in here, and now we see that TF state file in there. And so all of my other state files I should be able to remove, or more specifically, this state file I should be able to remove, and I think it's even empty anyway. So now if I do Terraform and plan, I should still see that I have a upcoming plan, and this is based off of the state that's on the object storage. It's a really easy thing to overlook, as you see, but it also shows us something really important, is how we can move our backend state file around if we need to. So just a little cleanup there. Let's get back to it. All right, so now what we're going to do is abstract away our cluster configuration here into variables themselves. So what I want to do is the easy ones first. So I'll just go ahead and grab these and bring it into terraform.tf vars and paste it in like that. I will actually add k8s underscore to each one of these things just in case we use other kinds of variables in the future. And so this is what I want to use for the variables for the cluster so I can change it at will. So I'm going to go ahead and copy this and paste all of these into my variables.tf now. And I'll actually use them as default values. So the first one, we'll go ahead and set variable. And this is going to be k8's label. And change this to saying default. And then we'll just go ahead and come in here, default. Of course, now this variable, if it is defined in terraform.tf vars, it's going to go based off of that. If it's not defined there, it will go based off of the default. Pretty neat. So let's actually copy this a few times for the other ones. So we've got K8's version, right? And then we will do the region. And then finally the tags. And there we go. Oh, that's a little copy and paste error there. And then with tags, what we want to do is we want to declare a type here, which is just a list of strings. So we just declare the list, which is these brackets here, and then inside of there, it's only strings. There is another kind of declaration that we will talk about, it's just not implement. So the next part is going to be, of course, our pool. So we'll do that in a moment, but in the meantime, I'm going to go ahead and change these to our variables. Notice if I type out var dot, it actually gives me the auto completion here, which is really nice and one of the reasons why you use VS Code as well as that third-party plugin that I showed you before. Next is the version, and then the actual region, and then of course the tags. So var k8's tags, which maybe is not being saved. And there we go. So with this in mind, let's go ahead and do Terraform and plan. Let's just make sure that everything's looking okay. Overall, it's fine. No errors, nothing like that. The next thing I want to do is the pool here. So there's two different ways on how we could approach this. We could abstract the entire block here to be in a variable, or I could just do the internal ones. And I'm just going to stick with the internal ones for now. So I'll go ahead and say K8's node type, set it equal to that. And then the K8's count. So K8's node count being that, or rather being 3. And then with that in mind, coming back in here, just paste those in and we'll do our variables just like we did before. This time the node count is just going to be a string, so we can declare string or it's going to default to that. So I'll just leave it in as that. And that's going to be our node type. But then our node count is going to be a number. We definitely want it to be a number and inferred as a number, even if we have it incorrect in terraform.tf vars. So of course, with this in mind, I can now use those as var.node type and then var.k8's node count. Great. So in the blog post, though, I show a way to do this more dynamically. So if you do a quick search on this blog post for the dynamic input variables, we see this right here. And this actually goes on how you can abstract away the entire object block. But that's just a little tedious to do and not necessarily something you will do for a bit. Like once you get a little bit more comfortable with Terraform, maybe you'll start to abstract that because you can actually have multiple pools for a Kubernetes cluster. We're just sticking with one, keep it nice and easy, nice and simple. Okay, so with this in mind, now that we have these variables, we can do Terraform and apply, and then I'm going to go ahead and say yes. Now this is actually going to take some time. On one test, it took about 25 minutes. On another test, it took about 5 minutes. This is actually interacting with the Linode API. So I'm going to let that run and finish. And then when we come back, we need to actually update our resource file here. And so that will happen very soon. Now my cluster is still being created here, but that doesn't mean I can't actually work on this K8's configuration file to actually have the correct data for it, or at least the data that's based off of this cluster resource. And that's what we want to do now. So one of the things that's really cool about using Terraform is that I can actually take an output from another resource. So in this case, the resource is a Linode LKE cluster dot, and the resource name for it is this right here. So that gives me access. Once this resource is created, that will give me access to various attributes of that resource. Now we find out what those attributes are on the Terraform registry. Inside of there, we click on our resources and we see this attributes reference. We click on that and here's all of those attributes. So I can use dot notation, much like I already started to grab something like .id, right? So the ID of the cluster. This would actually make that file full of just the ID. I can also use some of these other things, and more specifically the kubeconfig file, which is what I want. So kubeconfig. Now, for those of you who are already familiar with this process on the console, yes, you can still go into the console and still go and grab the Kubernetes cluster file, whichever one you're using, and you can download the cluster config file right there. There it is. No big deal. It looks like maybe it's already up and running, and I can verify that. Look, it is done. But I can also actually use that in this way. So essentially this local file would be able to go off of this config file and whatever that is. So let's go ahead and plan things out. Let's see what's happening here. So now what I should do is see the state has changed, and it also shows that it's forcing a replacement of a sensitive value. Pretty interesting. So I can now do apply, and I can just do auto-approve of this one. And this will not require me to type out yes, basically, for this change to happen. And if I go to kubeconfig.yaml, I see a bunch of gibberish, it seems. Now, this is actually not gibberish. This is base64 encoded data. And this is known because of the documentation. It says the base64 encoded kubeconfig file. So how do we actually decode this? Well, there is a built-in feature in Terraform to just go ahead and do base64 decode of that value. Just like that. What do you know? That's built into Terraform. So again, we'll go ahead and just apply it. Of course, you could plan it out, see what the plan is, and just go ahead and do it. And in this case, it actually did it. Okay. So one of the challenges, though, is maybe these tokens are correct. Maybe they're not. So what I want to do is also add in one more thing for my cluster, and that is changing this to non-sensitive. Even though it is sensitive, we want it to be non-sensitive data that's coming out of here. So non-sensitive is also built in to Kubernetes, or excuse me, Terraform's output. So we can use that. And again, we can actually apply it. And what we'll see is, well, basically the same data. Now, the thing about this kubeconfig file is we definitely do not want to share this with anybody. So I want to add this into Gitignore. One of the ways to do that is to copy the relative path and paste it in like that. Or of course, if you're using VS Code, you can actually just go ahead and control click or right click on this and hit add to Gitignore, and it will add it to the bottom of your Gitignore file. I put it on the top so I can see it, and it's there, it's right in my face. Okay, so before I actually start using this file though, I want it to be very clear that this kubeconfig file, I definitely do not want to have both checked in, but I also don't want to use it long term. What I want to use is something called RBAC, or role-based access control. So this is sort of a temporary measure when you first create your Kubernetes cluster to be able to connect with it. So in the long run, you would want to change this to doing something using RBAC, or role-based access control, for specific use cases, right? In this case, I'm doing it this way because we need to deploy things, and I'm not going to go through the entire process of implementing role-based access control for this particular series. But it is something that I highly recommend because this gives you unlimited access to the entire Kubernetes cluster, which again is not necessarily something you want to just have happen. And so in my case, I see that it looks like my kubeconfig is still coming in, right? So it's not actually ignoring it, but mostly because the original one just said data coming soon. So I'll have to change that in my Git settings and remove it from the repo itself, and also the cache. But overall, I now have a kubeconfig file that I'll be able to use inside and with my Kubernetes cluster, and that cluster is up and running. So what I'm actually going to do is tear it all down. So Terraform and apply -destroy. This is another way to write destroy, and then I can auto approve this, hit enter. This, of course, is going to destroy the whole cluster. It's going to destroy the kubeconfig file, everything. And that's okay. This is actually what we want to see from time to time. We want to be able to destroy entire cluster when we're testing things out, when we're learning. And if you start learning about role-based access control in Kubernetes, you can absolutely use this same method to be able to get really familiar with that just when in doubt. And of course, you're only charged for like the amount of usage you ended up using, which was minimal, at like maybe an hour at most, which is going to be what, 50 cents maybe? But anyways, that's that. Now we want to actually go ahead and come back to it and start provisioning some resources in Kubernetes. Now we're going to go ahead and do two things. That is re-provision our cluster and then configure kubectl. But first I want to make sure that kubectl even exists. So I'll do kubectl version, and I should get something like this, right? And it's showing that kubeconfig is not found at this point, which is okay. But at the very least, we're seeing that we have kubectl on our local machine. We don't see something like ABC version getting command not found, right? That's the important part. And I'm still on the root of my actual project here for Terraform. So I'll go ahead and do Terraform and apply. And then of course it's going to tell me all of the things it's going to do, which is building up our cluster. After it builds up our cluster, then it's going to create this file for me. So this is one of the things that I really appreciate about declarative programming, especially with Terraform, is that I didn't have to tell it, hey, make this resource, then this resource. It already knows because I'm referencing both resources, right? So this resource right here is referencing that one, which means that it knows that it has to do this one before it can do this one. It's really nice that it does that, and it makes things a lot easier, and I don't have to really worry about the organization or logic of it for Terraform. So I'm going to go ahead and create this cluster here, and it will take time. Like I said before, it's taken me 5 minutes sometimes. It's taken me 30 minutes sometimes. So it's really depending on how overloaded I suppose the Linode services are. So I'm going to let this finish, and then we're going to go ahead and just verify our nodes using kubectl. So going forward, though, I'm going to work in the root of my entire project. So not in the DevOps folder at all, because after I have everything configured and provisioned, I won't really need to use Terraform a whole lot more. I'll be using Kubernetes or kubectl pretty much exclusively going forward. But I'm going to let this finish, and then we will be right back. All right, so this time it took a little over 2 minutes. Great. So at this point, what I have on my VS Code workspace is that kubeconfig being associated to the kubeconfig environment variable. So if I just hit echo $kubeconfig, I see the absolute path to that particular file, right? So if you did it differently, then yeah, you're going to want to make sure that your environment variable has that value. And that's because now I can do kubectl get nodes, and this should show me my 3 nodes. Well, in this case, it's only one node. Only one node is ready, but it is showing me those nodes. And each one of those nodes, of course, corresponds inside of my Linode account to one of these nodes. I have quite a few running, but that's actually giving me those nodes, which is fantastic. So this is a really nice way to just verify that Kubernetes is up and running. And so now it's time to actually do a deployment as well as a service, just to really polish this whole thing off.